right? So what would be the agenda for this session? The agenda for this session is we would first understand what is database, why do we need a database, and what all schemas are. I mean, if you're understanding database, if you're going through database, what is a schema, what all types of databases we have. So all this information we'll try to understand, right? Now let's go to the next slide where it will it will give you a better clarity that why we need to go back and learn this database, why we need to go back and learn this schema, right? What is schema? What is database? What types of databases are there? And why SQL? Why not any programming language? Right. So let's suppose you're visiting a superstore, right? Superstore in the sense you're visiting a mall. Maybe you want to pick up some groceries. Now, what groceries you have? I mean, if you visit any particular supermarket or if you visit any particular mall, all that particular, maybe you are searching food items or maybe you are specifically searching biscuits, right? So you would directly visit that biscuit section because it is very easy, right? If you visit any superstore, you would go to that particular section where biscuits are mentioned or food items are mentioned, packed items are mentioned, and you can easily pick up that. Why? Because information is clearly arranged. The information is clearly arranged. So where is it clearly arranged? It can be arranged in a table form, right? It is usually arranged in a table format. So having been discussed yesterday, table has certain components. What component it has? If you consider from left to right, this left to right, so we have rows. This is left to right, and this is top to bottom. This is top to bottom. So whenever you are considering any database, the information is stored in a tabular format, right? It's a tabular format. So whichever information is kept from left to right, these are called as rows. Row 1, row 2, row 3, this is row 4. And the information which is from top to bottom, that information is specifically called as column. This is column 1, this is column 2, and this is column 3. So if you're considering a database, you should always remember that information is clearly kept in a table format. Now, coming back to the superstore again, I want to get certain items, right? So what items you can get? So I'm visiting a DMart. Let's suppose I visit a DMart. So if I'm particularly searching for a particular item, the item would be segregated in different partitions, right? In a different area, there would be different section. So you can easily visit that section and you can easily purchase that item. And where these items are kept, these items are kept in multiple rows or in multiple columns. So whenever you are considering a database, the database has to be clearly in the table format, right? Whichever information would be dumped into the database. Database is what? It is a storage system. So if you are considering any storage system, the information is either kept in left to right or top to bottom format, which are nothing but rows and columns. Now, this might be a pictorial representation, but along with pictorial representation, this is how, if you, and I mean, end of the day, if you purchase some product in the sense you purchased maybe 5 or 6 items and you went to billing. Now, what is billing? Right? If you want to, if you go to a billing counter, they would give you a bill, right? They would scan all these items which you have purchased, and with a specific barcode, a bill will be generated. Now, how that bill information, you went to counter, at the counter, a bill is generated. Where does that information get stored? That information will be stored in their billing system. Now, what is billing system? Billing system is nothing but your database. End of the day, wherever information is getting stored, that is nothing but your database. That is nothing but your backend system, right? So how the information is stored in the database? The same format. Whatever information is stored in the database, that information can be printed on the bill. So you purchase certain 9 products, how many quantities you purchased, what is the MRP, what kind of discount you have got from that superstore, And what's the total price? What's the total price? Now, this is just an MRP, right? I have multiplied it into number of quantities. So from that, with this discount, this is the total amount. End of the day, all this information is stored in rows and columns, right? The information which is stored in the database using that billing system, it would take a print of it, and that same print can be utilized for our reference. So whatever information you are considering, whatever information you are viewing it, all that information is always stored in the table format. That table format consists of rows and columns, right? Rows are from left to right, columns are from top to bottom. So just understand the structure. So database means table, table means row and column. Now, what is database? Database will store all the information. It might be physical database, it might be logical database. There are different databases. Just understand. Now, what is physical database? See, I'm visiting a superstore. In this superstore, you are physically picking an item, right? I want to pick up certain lace. I want to pick up certain, namkeen items. I want to pick up some biscuits, or I want to pick up some household products like soaps, right? We have oils. So I want to pick up that. You are physically visiting that specific rack and you're picking up that item. So that is nothing but a physical database. More a kind of there is a physical, you have an activity. And end of the day, whatever items you have picked, you visit a counter, and from that counter, a barcode is scanned, a bill is generated, but that bill is generated in their system, right? It is not generated in your device. It is generated in whatever superstore you're visiting, in their device, that bill is generated. That means there is a logical flow of information. You cannot physically check how, what is data, what information is stored in that bill. No, you can only check whatever is printed and whatever is given to you. That means there is a logical share of information. You're not physically touching anything, but you're getting a final copy of a bill. That means there is a logical share of information. So you need to understand what is physical database and what is logical database. Now we will discuss what is the ideal difference in further slides, but just to give you an idea, whatever you are considering, whichever information you are considering, every information end of the day is connected to database, and that database consists of a table, right? So table has rows and columns. That's the ideal structure. Now, any questions until now? Any questions?
No.
Okay, pretty good. Let's go to the next slide. Now, right, let's suppose the information is stored in this table. I want to check what kind of information is there. Now, we can see, this is a bill, we can easily see, but this is one single bill. Maybe you have purchased 9 products. That's the reason you can see all the information of products. But if that same superstore is visiting their billing software, they're visiting their billing software, and inside that billing software, they have maybe 1,000 bills which are generated for that particular day. 1,000 bills. They want to check what kind of products everyone has purchased. Not for a single bill, but for multiple bills. That means if 1,000 people have visited, all 1,000 people have generated bills. So the superstore analysis team, they want to go back and check the information. How would they go back and check? They would visit their billing software and they'll try to fetch that information using they will have certain communication, right? They will have certain communication. Now, what is that communication? What is that communication? Maybe I'll give you a small idea. Can anyone read this? Whatever information I've written, can anyone read this? Or out of this information, what is the understanding, what you have understood? Anyone out of 36 or 37 have joined, can anyone read this?
No.
right? You
No.
might have understood
No.
this information.
No.
Only this word you might have gone through SQL. Right now, let me change it. Slight change of information. Now, can anyone read this? Right?
Yeah.
Almost everyone can understood what I've written here. The same information was written here. The only difference is this is a different language. This is Japanese. This is a different language. Now, I mean, I assume that out of all 36 or 37, rarely or maybe there won't be anyone who understands this Japanese. But the second line or the second perspective is your SQL, right? It is more a kind of English. Now, what is English? English is a common communication language, right? So most of you understand easily, right? So if I use the last option also, even this option is easily understandable by most of, right? It's an Hindi, right? It's a common language which you can easily understand. So the language which is easily understandable, the language which is easily readable, that means you can easily communicate within that language. We cannot communicate in Japanese, right? Okay. There would be some people who might have communication in Japanese. But from the Indian point of view, from general perspective, which we are discussing, what we have all 36 or 37 folks, we can easily understand English. We can easily understand any language which is commonly spoken in India. That's the reason we can easily read the last two options rather than the first option. So the same way, if that billing team wants to communicate with their billing software, they need to know a language. It might be a programming language. So that programming language is called as SQL. The language which you can easily communicate with the database is called as SQL. The big question is why SQL? Why not any language? Because SQL is the most interactive way to communicate with the database. There are many other languages which can be used to communicate with the database, not only SQL, but SQL is the most interactive and easily understandable language. That is the reason people mostly use SQL as the database communication or database programming language, because whatever information is kept in that particular database, we can easily interact, we can easily extract, and we can easily maybe make some our own logics in the SQL, right? So if a particular mall or the owner of that mall or the data analysis team of that mall went back and they have 1000 bills which are generated on that particular day, they want to check at what time intervals how many number of bills were generated, right? So they can easily understand, maybe they can easily bifurcate different time intervals. Let's suppose they start their store at 10 a.m. in the morning. So from 10 to 2 p.m., how many bills were generated? From 2 to 6 p.m., how many bills were generated? And from 6 to 10 p.m., 10 p.m., they might close their mall. So from 6 to 10 p.m., again, how many bills are generated? So they can bifurcate. Now, how do you, I mean, how the data analysis team or how the superstores team, they would go back and communicate with this. They'll try to write a query in SQL that I want to check. I mean, you can easily write a query in SQL that from this time to this time, how many bills are generated? From this time to this time, how many bills are generated? So they will have that bifurcation. Now, what is the logic? Logic is you have to divide the time into 3 equal intervals here. Now, how to divide, how a logic is written, that's the further part. But if they want to communicate with that database, they have to use a programming language, they have to use a language, right? If I'm communicating with you, I'm communicating via English, right? English is easily understandable by everyone. That's the reason I'm trying to communicate with you. So the same way, if they want to communicate with the database, they have to communicate with the help of SQL, which is the most efficient and easily understandable language by the person who is trying to write that query and the database which will give you or which will retrieve the results. That is the reason SQL is one of the most commonly used database programming language. The reason why we learn SQL, because it is easily communicative, it is interactive way to communicate with that particular database. Now going further, why do we need a structured information? Right? We might have seen some information yesterday. Why do we need structured? Because it is easy to grasp that information. It is easy to check, right? The best example, dictionary. If anyone is visiting dictionary, maybe they want to search some information, they want to search a meaning of a particular word, they can check their index and they can go back to that page directly, right? Because information is clearly structured. We have an index, we have which particular word is present on what particular page. You can check that and you can directly visit that. Or the information is alphabetically sorted, right? If you go to a dictionary, even though if it doesn't has an index, you can alphabetically check what word I'm trying to search. So wherever the information is structured, it is easy to understand. Wherever the information is structured, it is very easy to understand. That's the reason the information needs to be a structured information. Now let's take one more example. Many might use Wikipedia to get some information, right? Many might be using Wikipedia, right? So if you visit a Wikipedia page, I want to search what is data analysis. What's the meaning of data analysis? So if you want to search what data analysis means, it is inspecting, cleaning, transforming, data modeling. I mean, there are many roles which a data analysis or data person, data analyst has, a business analyst has to do. But I want to search certain components of data analysis. Maybe what is the process of data analysis, right? The second part is the process of data analysis. But from that second part, I want to go back to some tools which are used or topics which are related to data analysis. So you need to scroll down, right? You need to scroll down on this particular Wikipedia page. You need to scroll down. But wherever you go, the information is clearly structured. That means you will always find an index or content page towards left or start of that page, which will directly jump you to that particular point which you are considering to understand. So the same happens in the dictionary, right? I want to particularly search a word. There is a word called as data. What does this data mean? So I want to search this word. So you open a dictionary. Once you open that dictionary, you directly go to the page where it starts, that page starts the word with D, right? D and then DA. So after DA, DAT. So you can directly, it is very easy to understand. Right. So the same way, if I want to search what is the meaning of analysis, what is the meaning of the word called as analysis? I can directly open this dictionary, open the page which starts with A, alphabet A, and then the second alphabet is N, third alphabet is A. So you can easily search that word, analysis or analyze, right? Dictionary doesn't have each and every word. It might have some, the basic understanding of that word. Analysis is a very big word. So analyze would have. So the information is cleaned, information is structured. That's the reason you can easily search in the dictionary. The same happens with any Wikipedia page. If you want to search any information in Wikipedia, the content of that page is always mentioned at the top towards left. So you can visit a particular content directly. So that's the reason a person who wants to communicate with the database has to be cleaned so that he can easily get that information. He can easily extract that information. That is the need of the structured information. Wherever you go, if the information is structured, you can easily fetch, right? If the information is not correctly structured, it might even take one day, even if you know how to communicate with that database, or it might even take 1 week also, or even it might take 1 year also to get a particular information from that database because it is not clearly structured. you have to write multiple maybe requirements, you have to write multiple filter conditions, which will again go back and see where that information is kept, what are you trying to fetch. So it's a very long process. If at all it's clearly structured, it can easily fetch that information. It's very fast, right? So the need of structured information is also equally important. Now, the next page will give you a better clarity. What is database? How the information is kept in the database, right? So this page will give you a better clarity. What is, why, and what do we need? I mean, what's the need of a database, right? Why do we need this database? So there are many points. I mean, if you go back, if you read this slide, there are many points which are related to data. The but most important point is it is very quick and easy to find. Why? Because information is clean, information is organized, right? If I go back to this slide, the information is structured, right? So whichever database you are considering, every database should be structured database. That is the reason it is very quick and easy to find that information. And does it mean that database can only store? Database can store the information. Data, whatever information you have stored in that, you can easily edit, you can easily delete, as well as if there are, right, I visited that super show, there are 1000 bills which they have generated on that particular day. So next day a fresh day starts, again they can add few more records, right? So whenever you are considering a database, it can add number of records, it can edit number of records, and it can delete number of records. So you can add, edit, delete, and edit means you can easily update whatever information is stored in the database. You can easily update that information as well. So a database can handle multiple tasks, right? So what is database? Database is a collaborative way where you can store your information. It can be easily shared with anyone. It can be easily shared with anyone. So I'll not read all these points because you can easily go through it. And the most important part is it can store large number of records as well. It can equally store large number of records as well. That is the reason people try to save their information in a particular database, and that database has a table which has rows and columns, right? So if I take, or if I give you the next example, this is how the information is stored in the database. The information is broken into table format, which is the storage format, and it has rows, which are sometimes called as records, and it has columns, which are sometimes called as fields. Now, what sometimes means, these are technical words. Records and fields are technical words from the database point of view. So for an example, there are 10 records in the customer table. So a record is a horizontal entity. That means it goes from left to right. This is horizontal, right? And whatever information is kept from top to bottom in a column, that is called as vertical entity. The table is the most important structure for any database. So this is how a table should look like, right? We have already seen a table, but how more specifically an information is stored in the database, this is how the information is stored in the database, right? So this is an instructor table. This table is an instructor table. So this instructor table has certain rows and certain columns, right? So there are 1, 2, 3, 4, 5, 6 rows, and 1, 2, 3, 4, 5, 6, right? The state is 6. So there are 6 rows and 6 columns. So row and column, you should always remember how a row and column is present in a table. Now, the most important part is you need to understand. See, if you're considering a row, it's just a small example. If you're considering a row, how a person can read that row? He will start reading the information with this instructor ID. Then he need to go to this first name. then he need to go to this last name, then he need to go to this address, city, and state. So if you're reading from left to right, which is one single row, you have to understand that there are different data types. Different information is kept in different components or different columns. But if I want to read a single column, maybe I want to read this first name. I need not change my perspective, right? I need not change my data type because for first name, it is the same data type from top to bottom, right? So why row is different, why column is different, you need to understand. Row, if you're reading, you have to change the data type for every person or every component here. But if you're reading one single column, from top to bottom, it will have that same data type. Now, why the reason why am I saying is going further, you need to understand where do we declare this data type? Do we declare it on a row or do we declare it on a column? Because understanding the data, in order to understand how the data is clearly segregated, you need to understand what kind of data it is, what data type it is. That is also equally important in a database. Right now, I have given you an idea what is physical database and what is logical database. In a database, the information is stored in the background, right? Let's suppose I want to create this table. I want to newly, I'm very new to this database. I want to create a new table. So if you want to create any new table, first you need to understand where you want to create, in which database you want to create. Right? A database doesn't mean it is only one single database. It might be multiple databases. So every database has a background structure, how the database should look alike, where the information should be kept in the database. So that background structure is called as a skeleton, right? If you are considering any example, maybe a person want to construct a new house, right? A person wants to construct a new house. New house is nothing but he will first, create a layout, right? He'll first create a design of that house, that what I want to construct. Or maybe a person wants to draw some information. So whenever you're drawing, you always have some rough marks, right? That this is how a drawing should look alike. This is where it should come. This is where some component should come. So the same way, whenever you are developing a database, whenever the information is stored in the database, there will be a skeleton. So that specific skeleton is called as a schema. That specific skeleton is called as a schema. Now, what schema is? A schema is nothing but a background structure that represents how the database should look like, where that information should be kept, right? Where that information should be kept. So when database is itself not present, but how the information should be stored in the database, you need to create a raw structure, right? So that raw structure is called as a schema. It is created prior to creation of a database. Because whenever you want to develop a structure, whenever you want to construct some new house, you first create the what is the idea, right? What we want to construct. The same way, whenever I want to create a database, I have to create a structure of the database that is nothing but a schema. Now, there are two schemas. What is physical schema and what is logical schema? We need to understand. You just go back to the question where I've mentioned what is physical database and what is logical database. Physical means you can easily touch and you can maybe you can feel that, okay, there is some information which is kept. So the same way, physical means it defines how data will be stored, right? If you're visiting a superstore, you want to fetch some information, you want to get some product. So you can easily read, okay, where this information is kept, and you can easily pick up that. That means there is a physical connection, right? Whereas the products which you are sharing it with the billing counter, they are just scanning it and they're giving you a billing copy. That copy, you are not the owner of that copy. You're just given a copy that you have purchased so and so products. You have to pay this amount. That is nothing but your logical. The same way you can correlate here, where and how the information will be stored, it is nothing but the physical database. And whatever information is stored, you're getting a copy of that information. That copy is nothing but a table format. That copy is nothing but a view. View is also one of the component present in the database, right? Going further, what all views are, what all tables are, we'll again try to go back and understand. But view, tables, integrities, these are all nothing but the completed structure. So that is called as a logical database. The information is already stored. You need to check, okay, where is it correctly stored or not? That is nothing but your logical database. Right? So there are two types of database schemas. One is physical database schema and one is logical database schema. Physical means where and how the data should be stored. Logical means the data is already stored, but what is the structure, right? How do you print that? So that is nothing but your logical database. So schemas is nothing but a skeleton. Prior creating any structure, you have to create a raw diagram of it. That raw diagram of a database is called as a schema of a database. One database can have different schemas, right? One database can have different schemas because you as a developer might have a different idea. Some other person as a developer might have a different idea. So every person can have their own schema. Now, what is SQL, right? We have understood that in order to communicate with a database, there should be a programming language. That language is called as SQL. In simple terms, SQL is a short form of structured query language. It's a short form, right? Now, there are many options, right? It's the fastest and easiest query language to communicate with data, right? It can execute, retrieve, insert, update, delete any queries, anything which is related to database. It can handle all that operations. Now, I mean, if any programming language is there, there might be some founder, right? It might have been invented by specific set of people. So who is the founder of the SQL? Who is the founder, right? Let's try to see, right? There are different, there are two people who have founded the SQL, but whenever they founded, right, you need to understand whatever language we are learning, is it a standard language or not? Right? English is a easily communicable and it's the most widely spoken, you can say, interactive language between all the people across the world. There are different languages accepted. Every region, every country has their own set of language. India itself has more than 50, 60 languages. That's a different part. But whichever language is easily communicable with everyone, that language should be a standard language. Now, how that standard language is? Because it is being authorized by certain set of companies. It is authorized by certain set of organizations. So SQL was authorized, or SQL have been become a standard language by these institutes. These institutes have given a standard recognition for SQL that it can be used to communicate with the database. This programming language can be used to communicate with the database. Now, I've been trying to say SQL, SQL, SQL. There are also other programming language if you want to communicate with the database. These are the different programming languages which you can communicate with the database. SQL is one, Python is one more language, R is one more language, Hadoop is also one more language, and Spark is also one more language. There are, I mean, is it that there are only 5 or 6 languages? No, there are many other programming languages which can be used to communicate with the database. But for all this language, 60% of the time people end up using SQL because SQL is easy, SQL is interactive, and SQL is fast as compared to any database programming language. I'm talking about any database. Now, if you might also have a question that why not Python, right? Python is also very powerful language. Yes, Python is equally powerful, but Python can be used to communicate with multiple other sources. SQL is only for a database. We are only talking about data. We're not talking about any other programming aspect or any other different, maybe a different technical aspect. It is only with related to data. So if you consider data, there has to be SQL. And if it's SQL, you can easily communicate with that database. Now, again, as I've said, SQL was introduced by few set of people. It was introduced in 1970s. There were two people, right? And these two people were part of IBM, right? There is a company called as IBM. These two scientists who have developed SQL are were engineers at IBM. Now, prior to 1970, was there no database? Was there no database? Is it that database was introduced in 1970s only? No. Database was prior to 1970 also, but the way of communication with the database was not SQL, it was a different programming language. Right? There were earlier different programming languages like COBOL, we have Pascal. These are all previous or these are all old programming languages which are nowhere used nowadays. But with the introduction of SQL, slowly after 1980s, it became a standard by ANSI and by ISO organizations. They approved SQL as the most commonly used database programming language. Right now, SQL is nothing but it's a very long word, SEQUEL. If you see, this is the complete word, but they have removed this E, U, and E. These vowels have been renamed and it has been given a short form called as SQL. See, they have removed E, U, and E. And in simple terms, it is structured query language. The language itself is a structure. So that means the information has to be in the structured manner. That's the reason people use it's easy to communicate. It is already structured language. Now, if you are learning SQL, you need to understand two important concepts. We'll only discuss what is OLTP, we'll only discuss what is OLAP, and maybe we can wind up what we are trying to understand today. Right? You might have got a better clarity about SQL, you might have got a better clarity about database, what is physical database, what is logical database, how the information is stored in the database. Everyone might have got a better clarity or better idea on that. And why only SQL? Why not any programming language? But if you are considering a SQL, there are two ways to store that information in a database or in a table form. There are two ways. Now, what that two ways are? The two ways are OLTP and OLAP. Now, forget about the examples, whatever examples are there. I'll only give you a small difference. Um, the information which is getting frequently updated is called as OLTP. The information which is getting frequently updated, it is called as OLTP. It is nothing but a transactional processing. So a person has a bank account, he holds a debit card and he visits the ATM. So he wants to withdraw some amount. So whatever amount he's withdrawing, that amount should be automatically subtracted from his total amount, right? His total account amount, what is present. If it isn't subtracted, the information will again remain same, right? So his account has some 10,000 rupees, but he's trying to withdraw some 5,000. So the balance should be 5,000. It shouldn't show 10,000. That is called as OLTP, the information which is getting updated transactionally. If there is a transaction happening, it should immediately update that information. That is called as OLTP. Now, whatever programming language we would be discussing in terms of SQL, everything is OLTP because it is fast. SQL, if you're learning, every information will be updated frequently. Every information will be updated at that particular time interval. That is the reason it is called as OLTP, online transactional processing. Now, there is the other component, which is online analytical processing, where we don't use SQL, where we use other database programming languages like Hadoop, Hive, Spark. These are all big data languages. Now, OLAP is nothing but your warehouse. Now, what is warehouse? Many might have a question, right? It's one of the frequently asked interview question. What is warehouse? What is lake house? What is database? Lakehouse means what is data lake, what is data warehouse, what is database. You need to understand the difference between all these three, right? So I'll give you a small example. What is the difference between these 3 or 4 components which we will be going through? Just a moment. Right, so let me take a new page. Now, one of the frequently asked interview question is, what is the difference between database, data warehouse, data lake, and there is one more component called as data mart, right? It's one of the frequently asked. And many might get confused that how the information is stored. Even if you know what's the meaning of data warehouse, what is the meaning of data lake, still people would get confused. So whenever you are trying to differentiate between the components related to data, which is data lake, always mention data lake at the very first instance. Then data warehouse you can mention. Then you can mention data mart. There is a component called as data mart. And at the last, you can mention database. So the short form of a database is DB, right? Now, these are the 4 components I want to differentiate among these 4 components. So let's take a small example. Any small example you consider, any product which is near to you, whichever product. So I have my mobile next to me. I have my mobile. I can see my mobile. I have this mobile next to me, which I've picked up now. So I mean, a mobile is a finished product, right? So let's suppose I'm trying to give a command to mobile. Maybe I've opened a lock. Immediately it will react, right? It will open that screen. So if I want to search a contact, I can go to the contacts option. I can search. Immediately it will search that information. That means there is an immediate change of information. That immediate change of information is nothing but your database. So you can assume that one single mobile, where all the information is structured, right? The information which is kept in the mobile, it is structured, right? You want to see photos, you will visit the gallery app. You want to play a game, you'll open a gaming app. Maybe you want to search contacts. The information in the contacts is also alphabetically sorted, right? Maybe I want to search something in the net browser. I'll visit a browser. So the information is clean, right? Information is structured. That means your mobile, that one single product which is mobile is your database, because everything is kept in a structured format. This is your mobile. Now, whenever you are whenever you are manufacturing a mobile, there are certain components, right, which need to be assembled together. That mobile is manufactured at a certain factory, right? Now, what is factory? In a factory, mobile is not in a structured format, right? Your screen is separately kept. Your motherboard is separately kept. There is a RAM. There are many other components which are present in that mobile, right? That finished product. So where all the components are separately kept, right? Let's suppose this is screen. This is your RAM, which is separately kept. There is, a mobile has a storage, right? So maybe you can assume that there is a SD card which is separately kept. Storage card, right? Now, mobile has many other components, like you have SIM card tray, which is also separately kept. So information which is all unstructured. Unstructured means you need to assemble them together to form a finished product. The information which is totally raw, that information is called as a data lake, right? The information in a data lake is not clean. It is all raw. You need to assemble them together to form a finished product. So the information where all the components are separately kept, all the components are totally raw components. That means the information itself is raw. That is called as a data lake. Now, data lake, you can take an example of a factory. Whenever you visit a factory, in a factory, all the raw materials are clubbed together. It might be a factory, it might be a manufacturing unit. So if you're considering a mobile, a company which manufactures this mobile, they have their manufacturing units where all the raw materials are kept. That are called as data lakes. And whenever all the raw materials are clubbed together, a finished product is formed, right? A finished product is formed. Where that finished products are kept, let's suppose a mobile is formed. A company is manufacturing a mobile. Company will never use a mobile. They'll only test and they'll pass it on, right? A person will again end user will again use it. But where do they store that information? A finished product. Wherever a product is manufactured at a manufacturing unit or a factory, it goes to certain warehouse. It goes to certain godown. Right? That information is certainly kept in certain warehouse. That warehouse is called as data warehouse. That finished products, there are 20 mobiles which are manufactured today. So all that 20 mobiles are kept in a certain warehouse is nothing but a data warehouse. Now, the question here is whether data warehouse is a structured product or a structured component, or is it an unstructured component? Data lake is purely unstructured because every raw material is separately kept. You have to assemble them together and then a finished product is formed. In case of data warehouse, the product itself is assembled. That means there is no raw data. But there is a chance that in a data warehouse, people might come and check whether the product is really working or not, right? They might check the status. They might check the stock, whether the product is present or not. So data warehouse is almost structured. You cannot call it as purely structured. It is almost structured. It is almost structured. That means it is a combination of structured as well as unstructured information. 70% of the time it is structured, you can assume. 30% of the time it is unstructured. That is called as data warehouse. The information which is kept in bulk order or bulk manner is called as data warehouse. A warehouse is nothing but where all the components are kept. Now, a company will never manufacture same kind of mobile, right? I mean, let's suppose you're considering Samsung. Samsung, it also manufacture premium segment mobiles, which are almost costing more than 30K or 35K Indian rupees. And the mobiles which are less than 30K are normal mobiles, right? Normal devices. These are not premium devices. So the same way, if you're considering in data warehouse, the information can be kept in different formats, right? All the premium mobiles will be kept in one single area. All the normal mobiles or semi-premium mobiles, right? Anything which ranges between 20 to 30K will be kept in certain area. And all the mobiles which will cost you less than 20K are normal, right? Normal segment mobiles, which will be kept in certain segregated area. That segregated area is called as data mart. Data mart is itself a part of data warehouse, right? So these are premium segments. This will be data mart 1. These are normal mobiles. This will be data mart 2. So data warehouse itself contains different data marts where all this similar information is.
Uh, can you again explain data warehouse?
Okay, I'll come back.
So in a data lake, only you said in data warehouse structured and unstructured. Right? So in data lake, when they ask what kind of data, we should tell it is just only raw data, not like structured.
100% purely unstructured.
Oh, purely unstructured in data lake.
Purely unstructured, 100%. Now let's understand an example, right? So I've created a data lake and I want to dump the information usually present in the data lake is unstructured, but I want to dump a structured information. Will it impact anything? I want to dump and maybe I have created a table which has some 100 records and there are 5 columns. 100 record means 100 rows and 5 columns. If I want to dump that information into data lake, it will easily take, right? It can easily take. But that doesn't mean the data lake is purely unstructured. That means you have to break that table and you have to dump that record. It can take structured information, but ideally, the information is purely unstructured in the data lake, right? So data lake is nothing but your factory. In a factory, whichever product is manufactured or assembled together, they go to a certain godown or a warehouse where that information is kept, right? Now, any product you consider, if you consider your laptop also, laptop is manufactured, maybe it is a product of HP, maybe it is a product of Dell. So it will be manufactured at that HP hub or Dell hub. From that hub, it goes to a warehouse where a bulk number of products are kept. From that warehouse, it goes to a shop where a single products can be kept for a display and it will be purchased by end user or customer. So the same way, if you're considering a mobile, it is totally raw, which is coming from the manufacturing unit, which will be assembled together. Once assembled, a bulk number of items will be stored at a particular location. That is nothing but a warehouse. Warehouse is not always structured, neither it is, it's purely unstructured. It is kind of combination of both. 70% of the time it is structured and 30% of the time it is unstructured. Within the data warehouse, there is a component called as data mart. Data mart is not separately kept. Data mart itself is a part of data warehouse, where all the similar products are kept are called as data marts. Right? Let's suppose I have a warehouse where I want to keep all the mobiles related to Samsung. I have a warehouse where I can purchase mobile from different manufacturing units. I have mobiles coming from Samsung unit. I have mobiles coming from Apple unit. I have mobiles coming from Motorola unit. So Motorola phones are all kept in one single area. Samsung phones are all kept in one single area. Apple phones are all kept in one single area. So that one single area where all similar products are kept, that is called as data mart. But data mart itself is a part of data warehouse, right? It itself is a part of data warehouse. It is not separate. All the data marts combine together to form a one single data warehouse. And what is data mart? Where all the similar products are kept. Where all the similar products are kept are called as data mart. And at the end, a single product is purchased by the user. That is called as database. Right? You are purchasing a single product at the end. That is called as database. And this is the most commonly asked interview question in any data related roles. What is data lake? What is data warehouse? What is data mart? And what is database? Database is purely structured. It cannot be unstructured. It is purely structured. Even data mart is structured. You can call data mart as also purely structured, but data lake is totally raw. That means it is totally unstructured. It doesn't mean that it is unstructured means it cannot take structured data. It can take, but 99% of the time it is unstructured. And coming to data warehouse, 70% of the time it is structured and 30% of the time it is unstructured. That's the ideal percentage of information. Right? So data lake is raw. Data warehouse is finished product most of the times. And inside this data warehouse, they have multiple data lakes which combine together to form a one single data warehouse. And from that data warehouse, it goes to database, which is purely structured.
And to retrieve, if you want to retrieve data from data lake, we cannot use a SQL. We have to use only. Okay.
We have to use the languages which it suits, unstructured, right? SQL is a structured language. SQL S itself stands for structure. So you can only retrieve information from the database if you're using SQL. If you want to retrieve information from data warehouse or data lake, you have to use big data programming languages. That was the reason, right? I was showing this slide where this slide says that you have to use Hadoop, Hive, or Spark if you want to search anything from the warehouse. Before warehouse also there is one more component called as data lake. Even from a data lake, you want to search anything, it should be different programming language. SQL is only used here, database, because it is purely structured. Any other questions on this explanation?
So in Snowflake also, we use the SQL to query, right? So
Yes,
SQL is also Snowflake is also the
a
data
database.
warehousing platform. So you just mentioned that
It
we
is
cannot
a
use X,
database.
huh?
SQL, Snowflake is not a data warehouse. It is a database. A database can have multiple, right? If I have 5 or 6 databases combined together, then you can call it as one single warehouse. Warehouse, I mean, again, I'm trying to say, warehouse, most of the times it is structured. 70% of the time it is structured. SQL is your Snowflake is not a warehouse, right? Warehouse is just a concept which is present inside that Snowflake. Snowflake is always structured database. It is a single database. It is always structured. SQL is one of the
Then why?
yeah. Good, good.
So why it is called data warehousing platform?
There are words given, right? Best example I'll give you. You visit
Uh-huh.
you're on the bike and you are driving back to your office or maybe your college. You stop at a particular junction where there is a signal. There is a signal. There is a red signal. Why to stop only on a red signal? Why to stop on a red signal? Right? There are certain rules which you have to follow. On red, you have to stop. On orange, you have to start your bike. Maybe you should be ready. On green, you should go. The same way, there are certain words given in the technical terminologies. Data warehouse is there, database is there. Now, do not compare Snowflake. Snowflake data warehouse is different, right? Snowflake is a cloud-based database which can be accessed in Azure, which can be accessed in AWS, which can be accessed in any other cloud. Snowflake comes with a combination of database and sometimes you can use some data warehouse functionalities also. Some data warehouse functionalities, not all data warehouse, some.
Mhm.
And in SQL also, there are different SQL databases, right? SQL is just a language. SQL is not a product. It's just a language, right? In Snowflake is a product. We have Oracle, which is a product. It's a database product. We have
Mhm.
MySQL. It's
So
a
is
database
Synapse
product.
is a
We have
data warehouse, sir? Is Synapse is a data
Synapse
warehouse?
is a data warehouse. Synapse is a data warehouse. Synapse comes with a combination of both data warehouse also and database. Because in Synapse, we have data storage, which is data lake systems, and it also has dedicated or serverless pool, which is nothing but your SQL. It is a combination of 4 products. It includes ADF, it includes Databricks notebooks, it includes ADLS, it includes SQL pool. 4 products are combined in Synapse.
Okay, thank you.
Someone had a question, right? There was. Any other questions?
So,
Hello.
Mm-hmm.
Yes, I am unable to understand difference between data warehouse and data mart.
Okay. See, again, coming back to the point. Data mart is a part and parcel of data warehouse. There is no separate component like data mart. Right? Database is separate. Data lake is separate. But data marts, you cannot create different data marts without data warehouse. If there is a data warehouse, that means data mart will come. So in data warehouse, just think logically that if I visit a warehouse, all the informations in the warehouse are kept in bulk manner, right? Maybe I'm visiting a warehouse where all the mobiles are kept. Warehouse doesn't mean that it will only have similar mobiles, right? It can have mobiles from different companies. Even if it has mobiles from a same company, there will be premium mobiles, there will be normal mobiles, there will be feature phones. Different mobiles will be there, right? So wherever the information kept is in similar format, different data marts combine together to form a one single warehouse. And what is data mart? Where all the similar set of information is kept. Maybe if I want, I'll take a I'll take a different example. If you consider any manufacturing, food manufacturing company, let's suppose you consider Parley. Parley manufactures normal glucose biscuits. Parle manufactures cream biscuits. Parle manufactures some cookies also. It also manufactures some different food items. It also manufactures some water bottles also, right? Bottled waters, the mineral water. So if a Parle can manufacture so many items, if you visit a Parle warehouse, do you think all the information in the warehouse will be totally unstructured? Right? They might keep all the biscuits in one single rack, glucose biscuits in one single area. They might keep multiple water bottles in one single area. So that single areas where all the similar products are kept, that is called as data mart. So data mart itself is a part of data warehouse. It is not different than warehouse. It itself is a part of data warehouse. Clear, or still you have a question?
So data mart anywhere, like to read data from data mart also we use SQL, how it will be
Yeah,
like.
you can say it is mostly SQL sometimes because it is structured, but as it is a part of warehouse, right? Warehouse can also have some unstructured information. Sometimes you have to use some big data programming languages. Sometimes.
Sometimes. Okay.
Because it can have some unstructured data, like 30% it can be unstructured, where you cannot easily segregate, that can be kept separate.
Sir, I have a question. So when you're mentioning these both terms, there is one thing that you're mentioning as data and the another one is you're mentioning as big data. So like what is the significant difference between these two terms?
Okay. Now, again, I have to go back to this example. OLTP and OLAP. Maybe we will discuss more about these in tomorrow's session. For time being, I might have not discussed, but just giving you an idea. If you're considering OLTP, right? OLTP is what? Database. It frequently updates immediately, right? If a person is withdrawing an amount from the ATM, it has to be updated in his account history, right? That it has to be debited. 10,000 is there, 5,000 he withdrawed, 5,000 is the current balance. But if that same person, let's take an example of UPI. You're using a UPI which is connected to a bank account. You use UPI for 5 rupees, 10 rupees also, and sometimes you use UPI for 5,000, 10,000 also. But end of the day, for that particular month, there are some 500 transactions which you have done using UPI. Now, with that 500 transactions, you can easily fetch that information from a single table, OLTP table. If you're considering for 1 month, you can fetch. If you're considering for 1 year, there will be 1 year means 500 per month on an average, more than 5,000 transactions. Still, you can easily fetch. If you're considering for 3 years, 15,000 records, you can still fetch. But as and when the number increases, right? For 10 years, you want to check all your transaction history, right? If you visit a bank, you want a statement. You want that mini statement for last 1 year or 2 years that bank can easily give. But if you're asking statement for last 10 years or 15 years, even bank will say, can you please sit? We need to go back and search that information. It will take some time because the data is big. It's vast, right? For last 10 years or 15 years, you want to check the transactions. So more the number of records, more the time it will take to process. So it will, I mean, you have to change that perspective to interact with that database, right? If the data is vast, you need to change the language. SQL cannot check vast number of records. So there is a limit. SQL sometimes can check 1 million records also, but it will take some time. But if you use any big data programming language like Spark or Hive, it can check that 1 million records within few seconds. So more the number of data, more would be the processing time for SQL to process. I'm not saying SQL cannot fetch. SQL can fetch, but the information has to be in the structured format. If it is unstructured, you have to go with big data languages because big data languages supports faster data processing. Again, we are learning database. We are not learning big data. We will learn database because database, there are limitations and the information is structured. The structured information is easy. Structured information is important for any data related roles. Unstructured, nowadays, more the number of information, more will be the unstructured data. I hope this might have cleared you, right?
Yes, thank you.
Any other questions? Now, prior going to questions, right? We just started with SQL. Now I've highlighted. Just give me a few seconds. I'll be opening. I'll be open to take your questions again. We have started with SQL today. Again, I have highlighted yesterday that you need to keep a target of 100 days. Next 100 days, you can keep a target, right? So what target you have to keep? That within next 100 days, I would be learning. I would be a good data analyst. I would be at a position that I can easily give any interviews and I can clear that any interview which the company is currently or looking to hire that particular role. Right. So you keep a target of 100 days. So today is day 1. You always keep a target and you can always go back and check, right? Some people would be busy today. They might have not attended this session. They can go back and check the recordings. But if you are not able to check the recording, that means you are skipping that 100 days target. So keep a target. 100 days is our next target. In these 100 days, I want to learn all the data analysis related technical aspects. Right. So today is day 1. Yesterday we might have started, but today is day 1 because today is what we started technically. And we started with SQL. What is the basics of SQL? What is database? How schemas are present, right? So today is day 1. Keep a target on whichever days you are completing, you're going through, you are understanding that concept. Only you have to consider that day and progress. Your progress should be continued. So tomorrow would be day 2. Now, what we would be learning in this particular course, we would be learning. Let me give you an idea. So we would be learning, we started with SQL. For a data analyst course, more specific to BI analysis, we would be starting with SQL, which is in-depth, we would be covering. Post that, there would be Power BI reporting, including Microsoft Fabric, which we have discussed yesterday. And then the Azure services. These 3 combined to form an Azure services. Right. So we would be learning, we'll be going through all these technical aspects in next 3.5 to 4 months. Right. Our target is 100. You keep that target. There will be here from 90 to 120 days, we will complete all these technical skills. But our target is 100 days. Right. Target in the sense you have to keep that target. Not me, but you have to keep that target. Right. So we would be going through all these technical skills in depth. We just started with SQL. There would be minimum 22 sessions of SQL. Monday to Friday, we have our sessions from 8 to 9:30 a.m. in the morning. All morning batch. I mean, mine is complete morning batch. Minimum 22 sessions for SQL. And Monday to Friday, 8 to 9:30 a.m. And again, having been said, from the KSR's end, do we only take technical sessions? No. From the current market point of perspective, we also cover what domain you need to understand. I mean, there are different domains, right? Healthcare domain, logistics or shipment domain. There would be some banking domain. So there are different verticals. There are different domains you need to understand. So we will be going through some domain understanding as well. We would also give you an idea about what is agile, how project management happens in agile. what is the current way of working in any company nowadays. That is more a kind of agile way of working. We will also assume your resume. We will understand it. Maybe you have to create your basic resumes. You can share it with us. Post that, right? Once we complete Power BI, then we can start with this resume building session. And we will also have some interview preparation sessions. So these are all non-technical, but these are all part and parcel of this course. You need not pay separately for them. These sessions are usually on weekends. Either of the weekend, I'll try to take off these sessions, which will be beneficial for you. Not now, maybe once we just complete SQL, we can start with some basics of domain knowledge along with Power BI. That's how this non-technical exposure would be. And the sessions would be for 3.5 to 4 months. Maximum, we keep a duration of 4 months. If here and there some buffer is there, right? We have some holidays in between, we have some festivals in between. So that is the reason we usually keep a buffer of 15 days, right? But the target is 100 days. You keep a target of 100 days, that within next 100 days, I would be a good data analyst. That you have to keep, right? So even if you're skipping today's session, you have to go back and understand what was discussed. You have to practice them, and then you can tick mark your day. That this is day 1, day 2, day 3. You can tick mark it. And what's the course fees? 30K is the course fees. There are different payment options. If you're paying it one single time, there is a discount, which our team will help you. But today is the second free session, right? There are still 3 more free sessions. You still have time. Will not say that you should pay and attend the sessions. You have ample time. You can attend the next 3 sessions. Then you can decide whether what you are able to understand. Then you can further have a discussion with our team, right? So you can easily connect with our team. The best option is you can easily visit. Let me show you. Right. So if you visit any browser, if you directly mention KSR Data Vision, you can easily visit our website. And from this website, if you want to get some additional, this website will give you all this information. Now, you might also have a question that I want to see what all technical skills will be discussed in all the SQL or this complete batch, right? What would we would be discussing, what would be covered. So if you want to check, right? Anyways, first 5 days sessions are live on YouTube. You can easily get the recordings. Now, how to get access to the recordings is, once you visit this website, you need to click on sign in. Now, once you click on sign in, you will go to this page. In this particular page, you will have an option. If you are already registered on our website, you can directly log in. If not, there is an option called as create a new account. If you click on this create a new account, it will ask you what should be your email ID. You can send an email ID. You can mention your email ID. It will send an OTP to verify your email ID. And once you verify that, it will ask you to create a password, temporary password or a password. Now, once that is mentioned, you can come down. You can click on login here. So whatever credentials, you can use your personal emails also to log into this website, right? So once you log into this website, you can go to this explore courses. Inside this explore courses, you go to free sessions. Inside this free sessions, the very first option, full stack Power BI, because we are yet to complete all our 5 free sessions, right? You can click here, right? So it would open and it will give you an access option, access course. You can easily access it. So once you click on access, it would be added to your bucket, right? So it would be automatically added to your bucket, and you can see there are few options here. Now, these are all previous batch recordings. These are all previous batch recordings. You can easily access them. Now, whenever you access this course, the very first process, the very first component it highlights is a PDF. This PDF is your course curriculum. You can download it. you will get an option called as download. Now you need to understand the difference, right? You are in the lessons option. If you want to access class records, maybe you have skipped today's recording or yesterday's recording, you can go to this class records and you can easily access. You see, yesterday's recording is view recording. It is available. Today's is still live. Once this session is done after 40 or 50 minutes, this recording would be auto updated or automatically available here. You can go back and check the recording. And next 3 sessions are already scheduled. So you can check your class records here. It would be same once you enroll also. Maybe again, we'll try to discuss it. That's the further process. What is course curriculum? This is course curriculum. If you're not able to check that course curriculum, that means you're in the wrong tab. You need to go to this lessons tab.
Show it again from how, like from after signing, where do I put it?
If you're asking a question, your voice is very low.
Sorry. Now am I audible?
Yeah, you're clear.
Yeah, sorry. My headphone was off. So I'm asking, like, can you please show it again? Like, how do we go,
Okay.
like, navigate to this
So
page
if
from
you
sign
go
in?
to Google,
Yeah, I've already
just
signed in.
yeah,
in
you have
case
already
of-
signed in. Okay. Now, once you sign in, once you open, you will get this explore courses option. Are you able to get that?
Yeah.
Click on that explore courses.
Mm-hmm.
Once you click on the explore courses, you will have multiple tabs: free sessions, upcoming sessions, paid
Yep,
sessions,
got it,
ongoing.
got it.
Go to free sessions.
Okay.
The very first tab, which is available, full stack Power BI with data analytics and MS Fabric preview, free preview. You have to click on that. Once you click on that, you will get an option called as enroll now or
Okay.
access now.
Yep, I've clicked on enroll now.
Yeah. So it would open this tab. It would open this window. Are you able to check that?
Yep, I've clicked on access now, and yeah, I've got it.
Oh,
Got it.
okay.
Thank you.
Yeah. So whatever information was supposed to be there, I've clearly shared it. And if anyone is following KSR nowadays, right? If you follow this KSR, right? Or maybe if you follow our YouTube channel, if you follow us on uh, Instagram also, or if you follow us on WhatsApp as well, right? If you're already part of certain WhatsApp uh, groups or WhatsApp community, um, you can easily see. You can easily go back and check what we are discussing on day-to-day basis, or how our progress is here in the KSR. You will get all an idea, better clarity there. Anyways, I would be highlighting here and there in between. I just wanted to make my idea or make my clarity or my thought clear that this would be a morning session, 8 to 9:30, Monday to Fridays. And having been said, target is of 100 days. So you have to go back. You have to click yourself. I can start my 100 days from today also. But the question is at what date you are starting and whether you are correctly matching your all 100 days. You should not skip one single day between. Again, open to questions.
So I have a question.
Mm-hmm.
So currently I'm pursuing business analytics. So I'm confused whether this course is right, or should I previously enrolled for the AIML course, but I couldn't attend due to my exam. So now I'm confused. Like, would it be better to pursue this or that course? So, like, what would make sense? So I'm doing my MBA in business analytics.
Okay. Okay, you're
Yeah.
pursuing MBA. You're in the first year or second year?
No, I'm in the last one semester is left out.
Okay, that means you're in the last year, fourth semester.
Mhm.
Yeah.
Yes.
Now, see, you have to decide business analytics. It's a combination of multiple things, right? Again,
Correct.
this course says that you will become a certified data or a BI analyst, business intelligence analyst.
Mhm.
Now, anyone I've clearly mentioned, right? Anyone from these background can take up this course. Now the question is, are you really interested in business analytics or data analytics? Or are you really interested in data science? The AI ML is more a kind of data science. It is a pure
Okay.
data science. There, okay. Now coming to this course has less programming concepts, more a kind of reporting or tool-based access, right? Power BI is more a kind of tool-based. Whatever we would be learning in SQL or DAX, it is more a kind of formula-based, right? A person who can understand English, they can easily write SQL queries. A person who can understand English, they can easily write SQL queries. But if you go to data science is more a kind of program oriented program. It's a program oriented course, right? There you need to learn Python, there you need to learn Hadoop, Spark, all these will come into picture. Now you have to decide which is best fit for you. Both the options are open. I'm not saying data science is bad. For few people, if they want to have a career growth in data science, for them that's the best course. If you're looking for a business analytics or business intelligence or data analysis or business intelligence, this is the right course.
Got it. Thank you. Thank you so much.
Any other questions? Right now, keep a target that you would be completing or you would be pro in this data analytics in next 100 days. That is the most important target. With that target, we will continue in tomorrow's session. I assume that there aren't any questions as of now. If you still have questions, please reach out us. Maybe if you want to contact us, the contact numbers are mentioned here. If you visit our website, the contact numbers are clearly mentioned, right? So you can go to this contact option. And once you scroll down, you will get these contact numbers. You can email us also if you have any questions, or you can have a chat with us here. You have this chat. Okay, if some of us, maybe some individual from the KSR team is not responding, that doesn't mean he will not respond. He might be busy now, but definitely we will reach out to you with your query. Whatever query you have posted in the WhatsApp, we will definitely reach out.
So where can I find the course like outline? Like
What outline?
you just mentioned, right? Correct. Okay, I got it. Like in the website in the first initial
First
leftmost
initial.
corner.
Yeah,
Yeah.
you
Thank
can
you.
download this PDF. Now, this PDF has all high level information, right? We would be discussing more than what is clearly mentioned. Right? This is all high level information because we did not mention every point. Usually we mention all high level information. Yes, with all this high level information, we will be covering. And you can go to the last page also. This is all our placements. I mean, placements in the sense, see, we give a support that, okay, what needs to be explained in the interviews? How do you clear interviews? That support is always given from the KS side, right? And we also refer people. We have good contacts. We also refer people. And if you are part of this, any WhatsApp communities nowadays, whatever placement you are seeing, out of which 50-60% placements are all referred by KSR folks. Even I try to refer. There are some other trainers who are also referring in their companies or their contacts. And even KSR has some good contacts. So if any openings are shared within the KSR, we usually try to reach out to people who are really working, who are really going through each and every session, right? We try to filter out them. In a batch, there can be 50 students, 100 students, 70 students, 80 students. Out of 80 students, we'll never share that opening with all 80. Usually, we reach out to people who are really attending. So that's the reason I always keep a target, right? Keep a target of that 100 days. So if you're frequently attending sessions or going through recordings, we can easily check who is attending, who is going through recordings. So we only reach out to them because we feel that that person is right fit for that particular role. There will be some general openings, right? If there are 50 open positions, 60 open positions, in that case, we publicly share. Uh, is there a way can we reach out to you directly, ma'am? I am going through the sessions. If you have any questions, you still okay? Is it Garvit? Okay, sorry, I mispronounced. Garvit, if you want to reach out to us, you can directly reach out to us. I mean, the contact numbers are of the team, right? They also know what technical, I mean, you have technical doubts, you have any issues with what you want to have a communication with, they will also help you. There are still 3 more days. If you have any other questions, please write it down. Maybe you can ask in tomorrow's session again. I'll try to answer it. Maybe not tomorrow, maybe next 3 sessions. Okay, I assume that there are no more questions. We're almost good for today. If you still have any other questions, please feel free to ask us in tomorrow's session, right? Expecting all of you again tomorrow in tomorrow's session. Thank you, everyone. Have a great day ahead. Let's connect back tomorrow.
Thank you. Goodbye.
Yeah, thank you.
Thank you.